Hello, welcome to Section 8, the final section of Chapter 1. Hope you've enjoyed Chapter 1 just as much as I had. Section 8 is titled Quadratic Models. A lot of story problems in Section 8. We're going to go ahead and start off with one as an example right now. A bakery sells cheesecakes having diameters either 6 inches, 8 inches, or 10 inches. That means that these are circles. Suppose they cost $8, $12, and $20 respectively. In Part A, you're to find a quadratic function. That means the highest power that you'll see is the second power. That models how the cost of cheesecake varies with the diameter. In other words, the cost is dependent upon the diameter, how big the cheesecake is. And then in Part B, which size cheesecake gives the most cheesecake per dollar? In other words, which one's the best buy? So I'm going to go ahead and move the problem over so I got a little more room to work. And we're going to do number 1, Part A. Now, to write a quadratic model, which is what it asked for, then we need something that takes on the form ax squared plus bx plus c. We need 3 things for a quadratic model. We need a, we need b, and we need c. Okay, and what we have 3 ordered pairs. In other words, we have 3 sets of x, y, and you say, what? Where did those come from? Well, if you remember, they told us that f of 6, in other words, for a 6-inch cheesecake, it was $8. $8. Well, so for a diameter, I'll just abbreviate DAI, for a diameter, i.e. the x of 6 inches, it cost $8. That's our cost. That's our y value. What were the other ordered pairs? F of 8 was $12, and a 10-inch cheesecake cost $20. Well, hey, there's 3 ordered pairs right there. So what we're going to do is use those ordered pairs and plug them in for x and y. And we're going to plug them into a generic quadratic model. So here we go. What is f of x? What does it stand for? It's really just y. So let's start with the first one. I'm going to put 8. I'm going to put 8 equals a times x. What do I put in for x? I put 6. That's the input. So 8 was the output, 6 was the input. Squared plus b times 6 plus c. I'm going to clean that up just a little bit. How does it clean up? That's equation number 1. Here it is. I'm going to erase this ordered pair so I got a little bit more room. It's 8 equals 6 squared is 36a plus 6b plus c. Alright, now just repeat the process. Do it again. This time though, the output was, what was that second cheesecake? F of 8 was $12. So the output is $12 when you have an 8-inch cheesecake. That's equation number 2. You may see where I'm going with this. 12 equals 64a plus 8b plus c. And then finally, equation number 3. It costs $20 for a 10-inch cheesecake. 10 squared is 100 plus 10b plus c. You have a system of 3 equations and 3 unknowns. So just like you would use elimination on a system with 2 equations and 2 unknowns, you're going to use elimination again, but you have to do it twice, and you have to eliminate the same variable both times. You did this in Algebra 2. Alright, so I need to make a little bit more room. Make this just a little bit, well, Can't figure out what goes where. There we go. Make that just a little smaller so that I have a little room. And here we go. Let's start with equation number 1. Now, equation number 1 has a c in it. It's right there. So does equation number 2. I could eliminate those c's if one of them was negative. So let's multiply the top equation by -1. It becomes -8. I suppose I should do this in pink to stay consistent. -8 equals -36a minus 6b minus c. Now, let's do equation number 2. And just leave it alone. 12 equals 64a plus 8b plus c. And notice the c's are gone, and we have a new equation. It's 4 equals 28a plus 2b. Let's call this equation number 4. Alright, sweet. So we've done an elimination one time. Now we have to do it again and eliminate the same variable both times. So we're going to use equation number 1. I'm going to use it again. Equation number 1, I'm going to use it again. And I'm going to multiply it by -1 again. And which equation do you think I'm going to put it with now? That should be a minus. Minus 6b minus c. I'm now going to put it with equation number 3. Because I've already used 1 and 2, so now I need to use 1 and 3. Equation 3 said 20 equals 100a plus 10b plus c. Let me get a new color out. Purple. Okay, so 12 equals, what would that be, 64a plus 4b, and that is equation number 5. So I've eliminated c 2 times. What do you think I should do next? Well, next I'm going to put equation number 4 with equation number 5. So I'm going to copy equation number 5 down here underneath 4. 12 equals 64a plus 4b. And now I'm going to use elimination again and eliminate another letter. So let's take the top equation times -2 to kill the b's. So -8, -56a minus 4b, and the bottom, 12. I should have written this in purple. My apologies. Plus 4b. And the b's are gone. -8 plus 12 is 4. That's 8a. And look here, a must be 1/2 when you divide by 8. Now that I know a, just pick him up and put him in either the green equation or the blue equation. I'm going to pick the green one. I'm going to put him right there. So, let me write this in green. 4 equals half of 28, because I'm replacing a with a half, is 14, plus 2b. And b there, let's see, that'd be -10 divided by 2 is -5. Yep. And now that I know those, a and b, I can pick up -5 and go to one of my original equations. So let's pick it up, and let's just go to this bottom equation and go right there. B is -5. A is 1/2. Put it right there. And, oh, I'm running out of space here. I'll just put it over here. So 20 on the right side of the screen here. 20 equals 100 times a half is 50. 10 times -5 is -50. Oh, that's nice. Plus c. So c is 20. All right, cool. And remember what I said earlier? Earlier I said that we needed a, b, and c. Well, guess what? We have a, b, and c. Let's write our equation. Dun da da da. I know you're excited. And here it is. Let me get this out of my way so I got a little room. f of x equals a is 1/2 x squared, b was -5, x plus c was 20. There is the quadratic model that will tell you how much a cheesecake costs dependent upon its diameter. So if you got a cheesecake that's got a 100-inch diameter, plug it in for x, it's going to tell you how much it costs. If you got a cheesecake that has a 1,000,000-inch diameter, plug it in, it'll tell you how much it costs. Now, the second question was to get which cheesecake has the best price. Well, remember, we're talking about circles, and we want to know, we're going to take the area of whatever your cake is divided by the price, and that'll give you the most bang for your buck. Remember, area of a circle, pi r squared. 6-inch cheesecake, what's the radius? Well, it's 3. So, let's see here, that would be 3 squared is 9, 9 times pi is 9 pi, divided by the price of that 6-inch cheesecake was 8. It's about $3.53 per square inch. $3.53 per square inch. I'm sorry, that's wrong. You get 3.53 square inches per dollar. That's what I needed to say. All right, for the 8-inch cheesecake, your radius would be 4. 4 squared is 16 pi. Divided by the price, it was $12. Here you get $4, or no, you get 4.19 square inches per dollar. So you get more bang for your buck with the 8-inch cheesecake than you do the 6-inch cheesecake. And finally, the 12-inch cheesecake, where R is 5, 25 pi. That cheesecake costs $20. Well, when you divide that, you only get 3.93 square inches per dollar. So which one's the best buy? Where do you get the most cheesecake for your dollar? You should buy the 8-inch cheesecake. If you need, 16 inches of cheesecake, then buy 2 of those. Don't buy one 12-inch and then a little 4-inch. So, there you go. Now, how can you tell if a linear model, or if a model is linear or quadratic? Well, if it's linear, then there's a constant rate of change. Constant rate of change. Think about a smooth line on a graph. It has a constant slope, which also means rate of change. So for instance here, for every x you're adding 1, right? Here we added 2. Now here we added 2, but wait a minute, we added 4 down here. What would that slope be? Well, change in y was 2 over 1, which is 2. The second time, the change in y was 4, change in x was 2, which is still 2. So that's a constant rate of change. The slope never changes. Now, for a quadratic model, you could have increasing or decreasing outputs. Increase or decrease in the rate of your outputs. Increase or decrease in the rate of your outputs. So for instance here, x went up by 3, but this went down 9. Here, x went up by 3 again, but then this went up 9. Well, see, it's increasing and decreasing. That's how you know you have a quadratic model. It's not constantly increasing or constantly decreasing. It's doing both. And that makes sense if you have a parabola, right? It decreases and then it goes back up. It increases. Whereas a line might always be increasing or always be decreasing. Okay, example number 2. Table below shows the height of a ball thrown upward. Find a rule. Now, a rule just means a function. Okay, it's just another word for function. Tell me what's the maximum height of the ball and when does it hit the ground. Now, normally I make my students go through this one on their own, but since I'm teaching this through a video, I'm going to kind of walk you through it. Might help you out. So, all right, so let's find our rule first. Now, here we're basically going to do everything we did in example number 1. I need my 3 ordered pairs. When I plug in 0 seconds, what's my height? 172. After 1 second, what's the height? What's the h? That's 112. So the ball went up. And then after 3 seconds, what's the height? 96. So it started to come back down, didn't it? Alright, so equation number 1. What's the output? It's 72. We're looking for A, B, and C. Remember, what are we plugging in for X? Here's X, here's Y. Here's X, here's Y. Here's X, here's Y. So in place of X, we're going to put a 0. Remember, it's A times X squared plus B times X plus C. Well, that equation, well, wait a minute. That just means what? That means 72 is C. Well, I like these kind of problems. That's cool. That means technically they gave us the y-intercept, guys, if you haven't picked up on that. Alright, and then 112, the second output. Input was 1, so that's A times 1 squared plus B times 1 plus C. So equation 2 just becomes 112 equals A plus B plus C. And then finally, equation 3, I'll just take a shortcut here. The output was 96. And what did we plug in? Oh, we plugged in 3. So 3 squared is 9A plus 3B plus C. Okay, what are your ideas? What do you want to do? Well, notice, we already know what C is. So that's cool. We already know what C is. What I would suggest doing is eliminating A or B and using equations 2 and 3. Because then we can take this C, plug it in, and get another variable. Watch, you'll see what I mean. So let's take equation number 2 and multiply it by negative 3. Negative 336 equals negative 3A minus 3B minus 3C. Now, why did I do that? Well, because now, with equations 3 and 2, the B's go away. Watch. See you later. All right, negative 96 minus, or positive 96 minus 336 is negative 240. 240. This is 6A minus 2C. Now, why was that a smart move? Because, wait a minute, Miss Williams, we already know C. Just pick him up. He's kind of heavy, though, so be careful. Put him right there. Now you can figure out what A is. So, negative 240 equals 6A minus, what's 2 times? So 144. So what does A end up being? I think after you do the algebra, A is negative 16. And now that you know A and you know C, pick one of your equations. I'm going to go equation number 2 and find B. So 112 equals A, which is negative 16, plus B, plus C, which is 72. Combine him and him, that's 56. And 112 minus 56 is 56. Sweet. So now we can write our equation. H of t equals negative 16t squared, or our rule, I should have said, not equation, plus 56t plus 72. Ding, ding, ding. There you go. That quadratic rule or quadratic model will tell you at any given time where the ball is, how high it is off the ground. Let's go to part B. Part B said to find the maximum height. Now think about a ball. A ball goes up in the air and it comes back down. Where will its maximum height occur? Well, if it makes a parabola, it would happen at the vertex. Now, which letter would be the height? Which letter would be the max height? The x value of the vertex or the y value? Well, height has to do with up and down, so I must be interested in the y value of the vertex. So how do I find the y value of the vertex? Let's write that out. Find y value, so when you look at your notes, of vertex. Well, before you can find an x, or before you can find a y, you must have the x value first. Must have x first. So do we know how to find the x value of a vertex? Is there any way to do that? Oh, wait a minute. I think I remember a handy-dandy little formula that helps me find x values of the vertex. That's right. It's opposite b over 2a. Well, the opposite of 56 is negative 56. This is the opposite of b. I'm getting this from the last screen. Over 2 times a, and a was negative 16. So that's negative 56 over negative 32, which becomes 7/4, or 1.75. Now this is in time. Technically, I guess I should have put t over here instead of x. So at 7/4 seconds, or 1.75 seconds, the ball is at its maximum height. Now that's your x value of the vertex. This is the x value of the vertex. I want the y value. So if you have x, how do you find y? Well, you just plug it in to your original model, which we found. Negative 16 times 1.75 squared plus 56 times 1.75 plus 72. And our ball will get 121 feet high. I just plugged and chugged that to the calculator. So x is time, y is height. T is time, h of t is height. It takes 1.75 seconds for the ball to reach 121 feet. That's its maximum height, the top of the parabola. And the last question asks, when will the ball hit the ground? So the question is really saying this: when will y, or h of t, equal 0? When will the ball, it starts out here at 72 feet, when will it go whoop, and hit the ground? That's what it wants to know. How long? Now we know it took, to get to here, the maximum height, it took, what was that distance? It took 1.75 seconds, and it reached a height of 121 feet. I want to know how long it takes to get down here, to this circle I'm filling in. Well, I can't just double the 1.75 because it's not symmetric, because the ball didn't start out on the ground. It started out at a height of 72 feet. But if I just want to know when will h of t be 0, then I'm really asking when will y be 0. So I'm just going to replace 0, or y, or h of t, with 0. All I'm really looking for, guys, is the x-intercept. And to find an x-intercept, you let y be 0. And this is the function that you generated. We can clean this up. Greatest common factor is negative 8, or 8. I'm going to do negative 8. So 0 divided by negative 8 is 0. 2t squared minus 7t minus 9. And guess what, guys? This bad boy factors. You say, yes. All right. Well, 2t squared is 2t and t. And 9 could be 9 and 1 or 3 and 3. What do you want to go with? 9 and 1. What'd you say? 9 and 1? Okay, 9 and 1. Let's go with 9 and 1. Sounds good. Let's do minus 9 plus 1. And looky there, you'll make negative 7 if you FOIL. So we get two answers. T could be 9/2 seconds, which is really 4.5 seconds. Or t could be negative 1 second. So when does the ball hit the ground? Well, silly, time can't be negative unless your name is Marty McFly in Back to the Future. No, time can only be positive, so the ball must hit the ground at 4.5 seconds after it started, after it left. This negative 1 is actually like representative of what the parabola would look like if it came back and actually, touched right there. But since time can only be positive, we only work in quadrant 1 for these kind of problems. All right, friends, that's all I have for section 8. Enjoy your homework. Get started on it. I'll talk to you later, folks. Have a good one. I'm out.